First thing that comes to our mind was ISRO. Now, private sector has also entered the body. It is completely made of carbon. Why everyone are racing towards launching satellites? So basically, what giving credit to the our forefathers. Hi guys, welcome to Believers IS Academy. So till now, especially what happened is whenever we think about something related to space, okay, the first thing that comes to our mind was ISRO, right? Indian Space Research Organization. This is ISRO used to come to our mind. Okay, ISRO has launched some space mission. However, recently on July 18th, what happened is India's first private sector has entered the space sector. Okay, the private sector till now it was completely controlled by the government. Now the space has been, the private sector has basically what entered this space sector, and the first space satellite has been launched. The name of the satellite is VIKRAM-1. Okay, so in this particular video, we'll be understanding what is this Vikram is all about, which space, what is that startup which has started this, especially space sector which has entered India's space sector. Okay, everything we'll learn in this particular video. Okay, so let's get started. So firstly, as I told you, VIKRAM-1, India's first private orbital rocket has been launched. This is a private agency which has entered Indian market. Okay, so this is the first thing. What happened is from the government monopoly. Earlier it was completely government, which was ISRO, was completely looking after this space sector. Now enterprises to private enterprises. Now private sector has also entered the space sector. Okay, India has entered the era where its own companies can launch satellites. Okay, so we had seen this. So now first is India's first private or orbital class rocket. Now what is this rocket? It is developed by whom? It is developed by a startup called as Skyroot Aerospace, which is in Hyderabad. Okay, this particular startup has developed this VIKRAM-1 satellite, and they have launched this satellite for lower Earth orbit, what we call as LEO, lower Earth orbit. They have launched this particular satellite for lower Earth orbit, and this is the first time. This is basically their first attempt, and they were able to achieve this success in their very first attempt. And okay, and this Vikram, the name Vikram is given due to the named after our father of our Indian space, whom we call as Dr. Vikram Sarabhai. Okay, he is considered to be the father of India's space program. Now this Vikram aircraft, basically what it had a payload capacity of 350 kgs. So what do you mean by payload? Let's imagine this is a truck. The truck is what we call as truck, and the goods. The truck we call it as rocket, and the goods which are in this truck is what we call as payload. Now what was the weight of this particular payload? It was 350 kgs, and it was sent to lower Earth orbit. As we all know, lower Earth orbit or the LEO is the most important topic when it comes to space. Why? Because in LEO, in lower Earth orbit, since it is very lower, very near to Earth's surface. So this is where all your satellites, okay, basically many of the satellites are being concentrated. Okay, and what was the name of the mission? Mission basically name was Aagaman. Aagaman, which basically means first step has been taken. The beginning. First step has been taken towards privatization of space sector. Okay, now this was very successful. Let's understand what are the details, and it was launched in where? Satish Dhawan Space Center in Sriharikota. Okay, so now we'll understand what is this specification about this particular mission. Okay, now if you see advanced indigenous, here the important word is indigenous. The word indigenous technology. Okay, here every part of the Vikram has been built within India itself. Okay, this is helping us to achieve what we call as Atmanirbhar Bharat. Okay, where indigenously we are not no longer dependent on other countries for production of our space station or the space basically what space launches, satellite launches. We are not dependent on other country, and it is Vikram-1 is a 7 story tall so tall multi-stage rocket vehicle developed entirely homegrown. Okay, homegrown engineering from its carbon composite airframe to its 3D printing machine. Now understand what are the components which actually was there in this particular thing. Now one is its structure. Basically it's a body. It is completely made of carbon. Now why it is completely made of carbon? Carbon is one of the thinnest, lightweight, okay, lightweight, and it has high strength. So when we are launching this particular satellite, the weight should be very less, because so it can go far away, weightless, and it has huge strength to accommodate any pressure which is there in the atmosphere. Okay, so maximum payload efficiency. Through this we can achieve maximum, because we can add more payloads. Payloads, I already told you, it's a kind of goods. We can add more payloads through this. Okay, so that's why it is, we have used which part? Carbon has been used in this particular thing. And next is, if you see 3D printed machines. So earlier what used to happen? Let's take an example of your bicycle. For bicycle, your handle will be separate, tire will be separate, the chain will be separate, the pedal will be separate. What we'll do? We'll use screw tools, okay, screw, and we'll fix it. Now here what we added is the 3D printing. The 3D printed machine itself will combine everything. Okay, so this is 3D printing, in-house developed propulsion with additive manufacture for its rapid production. And one is solid rocket boosters. Okay, solid rocket booster, it's a high thrust solid boosters designed for reliable cost efficiency and launches. Now what is this boosters? Let's example solid rocket boosters. Now what is the solid rocket boosters? Let's example, you have to pull basically a truck has been broke down, so now you have to push the truck. Now you need some 5 to 6 people to pull it. Okay, 5 to 6 people. Once it gets momentum, you only need a driver. The driver will drive it. So that's why these rocket boosters are like these 5 to 6 people. Okay, this will help the rocket to go out of this Earth's gravitational pull and revolve around lower Earth orbit. Okay, so this is the importance of this. And rapid manufacturing. Say for example, if I take an example of restaurants, there are two restaurant 1 and restaurant 2. Now restaurant 1, what they'll do? They'll basically this restaurant 1, whatever the food is ordered by the customer, it will prepare from the scratch. Okay, this is one thing. And here, since they've already made, they already made this recipe, or the whatever the requirement masala is already prepared, it's very quick for them to give it. So this is exactly what happened through this mission. They have their frequent launches. Through this, they know how to do it, and the launches will be much more faster. Here in restaurant 1, it was very slow. Why? Because they were developing from the scratch every time. So here R2, they already had the basically all the masalas, everything everything ready. So whenever the customers ask, they used to give faster. Now here also, so after this particular, now they know how to do launching and all. The future satellite launch will be much more faster for them. Okay, so this is how rapid manufacturing will happen. Okay, because of this particular thing. Now if you see this, what are the stages? Mission Aagaman, the historic maiden flight. How it started? The phase 1 liftoff and boosters burning. As I told you, boosters are like those 5 to 6 people who will push it. Okay, boosters started burning, and stage separation. Every stages, the boosters, the 5 to 6 people will come off, because since already the truck is getting momentum. Okay, these 5 to 6 people slowly, one by one, they'll come out of. This is what we call as stage separation. Okay, now third stage, the burning of payload, it will happen. And lastly, orbital insertion, and satellite will be deployed when they go out of the Earth's gravitational force. Okay, as I told you, it started in 18th July 2026, and it took flight duration was of 15 to 16 minutes. As I told you, it was low Earth orbit. Targeted orbit was from Earth's surface for 450 kilometers from the Earth's surface. From the Earth's surface, it was 450 kilometers, and result, as we all know, it was successfully inserted this particular payload. Okay. Now, if you see this, if you see this particular thing, now what is race to lower Earth orbit. Why everyone are racing towards launching satellites? This particular, okay, to lower Earth orbit. If you see this lower Earth orbit, as I told you, it is spread around 160 kilometers to 2000 kilometers. Now, say for example, if some person is around 10 meters from you and another person is some 10 kilometers is 10 kilometers away. Now the person who is 10 meters away, you can communicate easily, with him you can communicate very easily compared to the person who was 10. So that's why most satellites or the most countries wants to have dominance in their lower Earth orbit. Okay, through this satellite launch, India has also started dominating in this particular stages of the space. Okay, lower Earth orbit. Okay, now what will happen? Now since we are launching satellite in lower Earth orbit, what are the advantages? Is first thing is low communication delay. The communication will be faster. Okay, as I told you, compared to 10 meters, the 10 kilometers, here the communication will be much more faster, clearer images of the Earth and better internet connectivity. The internet connectivity much more faster, especially if you take some areas, say for example Ladakh, or you can take example of Northeast, where it is very difficult terrains are there. Okay, terrains are very difficult. So in these cases, these lower Earth orbit satellites will be much more useful for connectivity or communication and even to assess disaster. Okay, the satellites completes here in lower Earth orbit, it will take almost 90 to 120 minutes to complete their entire robot. I mean, complete their orbit. In order to complete their one orbit, they'll take 90 to 120 minutes. Okay, here as I already told you, internet communication will be much more enhanced. Weather prediction or agriculture, soil moisture, everything we can predict much more easier. Okay, and climate monitoring will be much more helpful. That's why all the countries, and when it comes to defense also, even in defense as well, it will be much more helpful for the countries. Okay, for the better communication, even your GPS also. Okay, GPS also much more enhanced or strengthened. Okay, we can say this. Okay, now after this, what will happen is why it is more just a launch vehicle. Here, as I told you, the carried a diverse manifested from communication to symbolize artificial artifacts celebrating India's scientific legacy. So what will happen is they have launched some of the payloads has been launched. Okay, Graha space, Cosmosurface. Now, what is this Cosmosurface? Cosmosurface basically is, let's say there is one thing, there is dead satellites and space debris. Now, this particular mission has helped us to reduce these of the dead satellites and space. We can use these kinds of satellites to remove this dead satellites and space debris. Okay, and what is the symbolic is which we call as cosmic bloom. The diamond artwork in the space. Okay, and 18 karat gold miniature rocket replica was also launched, and even the micro sculptures of C.V. Raman, Vikram Sarabhai and APJ Abdul Kalam was also launched in this particular thing. Okay, basically what? This is a kind of symbolic payload. What do you mean by symbolic payload? It's basically what? Giving credit to the our forefathers who were there. Okay, it's a kind of tribute they had given. And here one of the technical payloads these are some of the technical payloads which was launched along with this. Okay, now after this, why matters beyond the space? First thing is economic impact. Okay, now these companies can actually launch satellites and for satellites which are getting from their smaller countries. Okay, smaller countries and even the bigger countries, developed countries also, they can depend on this particular thing where it will enhance economic inflow of funds in this particular sector. Second is strategic sovereignty. Okay, we don't need to depend on other or foreign countries when it comes to our advancement in technology, and even for our defense also, we no longer basically depend on some other countries. Second one is technological leadership. Through this, since India had already has its name in one of the world's most developed space technological country, this has basically what it has added to this particular name, and this is the only third country after US and China with separate orbital launch capability. Okay, this is the only third country. Now we have only USA and China. Okay, now after this, India's future in global space race, what will happen today? It has proven orbital capability, growing the launch of credence and first commercial customers. Okay, it is not just a rocket; it's an opening chapter for India. Now, along with this, Skyroot Aerospace, many of the other space agencies will also, other space startup will come in. I mean, they also start this kind of research. This will go hand to hand along with government and private sector. Okay, they will go in hand to hand, which will also boost our Make in India. Okay, Make in India, Atmanirbhar Bharat. Okay, so this will enhance this, and near future reusable vehicles. Okay, and satellite mega constellation and space debris mission will be conducted in the near future. Vision is to India as a dominant player of global commercial space economy. Okay, I hope you have understood this particular topic. Okay, India's space sector, where earlier it was only ISRO, now we have private space agencies or private startups related to this space sector has entered in this particular field. I hope this video was much more helpful for you. Okay, through this, thank you so much.